to show you some of these ideas. Obviously, hopefully we know these reciprocal ones are true. But if I were to, I've just got an angle theta here. So this is my input. I'm going to be allowed to change it, right? We just said that, or we know that the secant of theta, if I hit enter, okay, and I wanted to grab that real quick. Okay. So secant of theta, when theta is 148, is that, right? What's the reciprocal of secant? Okay, so 1 divided by cosine then should be the exact same thing, right? Is that right, everyone? So if I hit enter, I get that number right there, right? Those two numbers, so you see this one here. If I highlight it, secant of theta. This one here is being calculated by 1 divided by cosine of theta, right? And as I change theta, what do you see about the left-hand side and the right-hand side? What do you see about those numbers A and B? They're the exact same thing, regardless of what I plug in, right? So when I equate that with that, we get an identity, okay? No matter what your input value is, you get the same exact output on both sides, okay? This statement is always 100% of the time true, okay? Now, hopefully we know these top three, okay? But I want to talk about the tangent of theta, okay, and why this makes sense, why that's true. We're going to use this one a lot. So if I take, let's just deal with sine and cosine real quick. What is the sine? If I use SOHCAHTOA, the sine of theta is what? Opposite over hypotenuse, okay? Cosine of theta is what? Adjacent over hypotenuse. And tangent of theta is what? Opposite over adjacent. Okay. Now, this little activity here that we're going to go through is hopefully an eye-opener to you of how you are going to get better at your algebra throughout this course, because the relationships that we make here are going to create something new for us, but we're just using algebraic ideas, algebraic processes that we have known since maybe Algebra 1. Okay, just doing some convenient substitutions really here. I'm going to solve that for O. So what do I multiply both sides to solve that for O? H. So H sine of theta is equal to O, right? I'm going to solve this one for A. Okay, so solve that cosine theta for A. So I'm going to multiply both sides by H again, right? So H cosine of theta is equal to A. Do we have an O and an A over here? So let's take that O that we just found as being H sine of theta, and let's put it right there. H sine of theta is equal to that O. And do I have, this was A on the bottom, right? Have I solved for A here? So H cosine of theta. What happens to your H's? Cancel out. So we get cosine of theta divided by sine of theta. Okay? So that is a lot of times referred to as a reciprocal identity. Oh, did I mess that? Oh, I'm sorry. For some reason I was saying cotangent, because I'm going to try to explain that next. So that's sine of theta. My apologies. Sine of theta over cosine of theta. But that is your sometimes referred to as a reciprocal identity, or categorized in that. Sometimes it's referred to as a ratio identity. But no matter what, if I take, let's see here. Let's go back to GeoGebra. Desmos doesn't allow you to do this. Oh. All right, so if I take sine of theta, obviously, is that value. Cosine of theta is that value, and they're obviously different, right? Okay, but when I take sine of theta and I divide it by cosine of theta, it gives me that. Okay, and then if I take tangent of theta, the relationship should be that these last two numbers that I've typed in here should be the same. So C and D here, C being sine of theta divided by cosine of theta, and D being tangent of theta. So what I want you to understand is that GeoGebra is calculating these two things differently, right? It's looking at different components of our angle to come up with these numbers. And these numbers here are going to vary, right? Okay, as I change theta, those numbers vary. Okay, the top and bottom. So sine and cosine, and I don't know if those are necessary to have in there, but they are different. Let's just look at the relationship there. Okay. Now we'll talk eventually. What did I have that on? 90 degrees. What that means to us. Okay. This number is undefined. Okay. We'll talk about why. And this one here is showing me essentially infinity there, which is a problem. So GeoGebra's run into an issue there. But elsewhere, okay, yeah, because it doesn't do any of it. Elsewhere, we see the relationship is always the same, right? Okay. So that's an important identity that we need to know that is true. And the reason we learn these identities is they're substitution tools for us. We might be in an equation or in a problem somewhere where we see tangent of theta, and it might be more convenient in regards to solving the problem to replace tangent of theta with sine over cosine. Okay. Now, tangent and cotangent are reciprocals, right? So if I take the reciprocal of tangent and I turn it into cotangent, I better take the reciprocal. So what I'm saying here is take that number there and that number there. Those are reciprocals, right? So if I take tangent's reciprocal, I should get cotangent. So then what do I got to do with that thing? Flip it. Take its reciprocal. So I get that other identity over there on the right. So the cotangent is cosine over sine. Okay. Now, the next identities exist because of Pythagoras. Okay, and we're going to talk about these a lot throughout the course. This one here is extremely useful to you. Okay, it's going to actually be kind of the basis for many, many more identities. I showed the last class this. Just kind of zoom through this real quick. These are all identities that we're going to kind of mess around with throughout the year. Okay. Now, you're not going to have to memorize all of them. Okay. My hopes are that you're going to develop an understanding of a set of fundamental ones. You already know SOHCAHTOA. You know the reciprocals. I'm going to teach you these. You know the sine over cosine one is equal to tangent now. And now, with a collection of those and some good algebra skills, you can develop all the other ones. Okay? And that's my goal, is not to memorize things. Because, and I said this the last class, if you would have asked me today, right off the top of my head, can I say these two identities correctly, I probably wouldn't have been able to do it. Okay? Because I don't have them memorized. But I understand how they are developed from this one. And I understand where this one comes from. And so do you. Okay? We'll talk about, every time I put a right triangle in the coordinate plane, and let's just center our right triangle at 0, 0 here. Okay, so, I trace out this theta, correct? And it doesn't have to be in just the first, it could be any quadrant we want to. But let's say, just for our convenience sake, that theta is 30 degrees. And I'm going to make this here 1. Because that radius could be anything it wants to be, right? 1 might be an easy value to deal with. That's 1/2. And then this side here would be root 3 over 2, right? Just using our special right triangle information. Okay? Now, what I want you to understand is that this is true regardless of theta. And I'll hopefully have time to prove this to you with GeoGebra. But if I take, let's say what sine... I'm talk about this notation here in a moment, but we're saying sine squared of, now for our particular question, it's 30 degrees plus cosine squared of 30 degrees is equal to 1. Now that really means this, sine of 30 squared plus cosine of 30 squared is equal to 1. Okay, this power of 2, we'll talk about that. We're going to run out of time today, but that notation is important. We'll talk about that soon. But what is if I look at this picture, sine of 30 would be opposite divided by hypotenuse, right? So it'd be 1/2. And then we'll square that. Cosine of 30 would be that number right there, right? Divided by my hypotenuse of 1. So it's just root 3 over 2 squared. Does that equal 1? What's 1/2 squared? 1/4. What's root 3/2 squared? 3/4. Does that equal 1? And the idea is that regardless of what that theta is, you're always going to get 1. And if we show that here, okay, now obviously sine of theta and cosine of theta, those are going to be varying numbers. They're going to be different. But if I take this number here, my A value, and that's going to be sine of theta, and I'm going to square that. Add to it the cosine of theta, and I'm going to square that. Hit enter, and I get 1, right? So you see it, that's sine, that's cosine, that's the sum, or their squares summed together. And as I choose the number theta, you see that the components sine and cosine change, right? Okay, so I'm changing that angle from a 30 degree to a 60 degree to whatever degree I want it to be. When I square those components and add them together, I always get 1, right? So that's an identity that's always true. No matter what your input value is, you are always going to get that result back, okay? Now, we'll talk about these on Monday. These two things are direct conclusions from sine squared plus cosine squared equals 1, okay? I'm going to extend both homework assignments, 5.3 and 2.1, so be on the lookout on an email telling you when those are due. Thank you, too.
Have a great day, Mr. Baker.
I will.